Hi everyone, my name is Manvi Gumba and today I'm going to show you my assignment 3 for Applied Data Science COM 3122 and my student ID is 101412099. So let's begin with that. So basically I will be walking you through the code used to predict the house prices using the machine learning. So let's begin with that. So basically I have created an account on Kaggle and then you can see I have submitted it and my public score is 015 as according to the requirements. It should be less than zero point 0.3, so my score is 0.15, I think, which will be okay. So let me walk you through the code. So I have created assignment 3 Python file in Jupyter Notebook, and I have taken the test.csv and train.csv from the Kaggle. And so let's begin with the code. So basically, I have imported all the necessary libraries here, and as you know, that pandas help us to manipulate the data set. NumPy provides the support for numerical operations and more. So then we are gonna load the data. So basically, we are loading the training and testing data using the pandas here, and then we're gonna once the data is loaded, we will inspect its structure and check for any missing values. So basically here info function gives us the basic information of the data set, such as number of rows and columns, and the head function displays the first few rows so that we can see the sample of the data. And then you can see here it is printed, and then you can see here next we are gonna handle the missing values in the data set. So basically if we check here for missing data in the training data set, like for numerical values, we replace the missing values with the median values, and for the categorical columns we will fill the missing entities with the mode, which is the most frequent value. And then we are going to do the feature engineering and the log transformation. So basically we prepare the data for performing some transformation, and here I apply a log transformation to, like, here I have used the grl live area and lot area columns. The log transformation help us to reduce the sickness and makes the distribution of these features to be like more normal. And when we are gonna visualize the data, the visualize the correlation matrix to understand the relationship between the features. So this heat map help us to see how strongly different features are correlated with each other and which ones are the most correlated with the target value, which is like here is sales price. And then next we are going to define our features and target the variables for the same. So X contains the independent variable and Y contains the target value, which is the price of the house. And then we are gonna train, test, split. So basically we split the data into training and validation sets. We allocate the 80% of the data to training and 20% of the data to evaluate the model performance. And then we are gonna initialize and train the random forest model. The random forest model is basically an assemble learning algorithm. And then we are gonna make the predictions. So after training the model, we evaluate its performance on the validation set. So we calculate the mean squared to measure the accuracy of the model prediction. The lower RMC indicates the better model performance. So basically after that, to improve the model, I have performed the hyperparameter using the randomized search CV. Here, and then we're going to search for the best hyperparameters for our model by randomly sampling the samples of the set of the possible values. And then we are gonna, after finding the best parameters, we evaluate the performance of the optimized model. And then we're gonna use the best models found by the randomized search CV and evaluates its performance using the RMSE, and then we are going to apply the same processing steps to the test data so that we can ensure that the test data set is also pre-processed by the same way as the training data set. And then we are going to generate the predictions on the test data. So here is the code for the same. So for the test data, so basically the model predicts the house prices and we reverse the log transformation using the np dot xmmp function to return the prices to the original scale. And then at the last, we are finally creating a submission file to save the prediction, which is like a CSV file. So basically, this code will generate the. I have imported the file. I have imported here from file link from the python.display so that I can generate a CSV file containing the house ID, the predicted sale price, so that we can submit it for evaluation. So here you can see my submission.csv, which has the ID and the sale price, and I have submitted it on the Kaggle. And through my submission, you can see my score, which is 0.15241. That's it for my assignment 3. Thank you.